Okay, last part of 4.3, where we're going to solve some trigonometric equations. So in some cases, when you solve these equations, you're going to get an exact value to work with, and exact values that are on the unit circle. So we'll use the unit circle to find our solutions. But in other cases, you will not end up with a value that's on the unit circle. So we have to approximate our solutions. And so we'll be doing that by using our cast rule and using our calculator to find the reference angle. So how can you find the measure of an angle when the value of the trig ratio is given? To reverse this process, for example, to find theta, if you know what sine theta is, we use the inverse trig function keys on our calculator. So for example, if sine of theta is 0.5, and you want to know what theta is, you're going to go second function sine of 0.5. Now you can see in the example, it says our answer is in degrees, 30 degrees. So to get that, you have to be in the degree mode. So in degrees, if you go second function sine of 0.5, your calculator is going to tell you what angle exists such that the sine of that angle is exactly 0.5. And you get an answer of 30. Okay? However, we're going to see that there's another place on the unit circle, or another place on as a rotation angle where the sine of theta equals 0.5. Your calculator will only give you the principal angle, or the angle between 0 and 90 degrees. But there's often going to be a second angle that'll work. So we'll see how we find that. And if you're asked to give your answer in radians, then you can do it on your calculator, only now we have to be in radian mode. And now when you go second function sine of 0.5, it gives you your answer in radians. But your calculator in this case gives you a decimal that you'd have to round. However, if you remember from your unit circle, there is a spot on the unit circle where you have a value of 1/2 for a y component. And so if you can use exact values, you will. So if you're going to see some of those same numbers that we saw from our unit circle, 1/2, √3/2, √2/2. With tangent, we dealt with 1, with √3, and √3/3. Okay, so if we see any of those values as we go through this, that's going to be our hint to go and use our unit circle. So those calculator keys, sine to the -1, cos to the -1, and tan to the -1, return one answer only, which I mentioned a few minutes ago, when there are often two angles with the same trig function value in any full rotation. So in general, it's best to use the reference angle applied to the appropriate quadrants, which we'll use our cast rule for, along with that reference angle to get the terminal arm of our angle. So this first example says, determine the measure of all angles that satisfy the following. Use diagrams in our explanation. And the first one says the sine of theta is 0.879. And we're going to be working in radians here because we're told our domain is between 0 and 2 pi. So that value of 0.879 was not on the unit circle. Remember, it was 1/2, it was √3/2, it was 1, it was √3, √3/3. So those are all the values that we kept seeing as we went through our unit circle. 0.879 is not part of it. When it's given as a decimal, chances are it's not from the unit circle, unless it was 0.5. Okay? So here's how we do these. We start with an xy axis. And in this case, the sine of theta, and there's two things that are important here. The decimal value is important, but also whether it's positive or negative. this decimal value is positive 0.879. And so using our cast rule, we need to look and see which quadrants sign is positive, which would be quadrants 1 and 2. That's where the sign is positive. So we know our terminal arms will lie in one of those two quadrants, both of them. We're going to get two different answers here. So that's the first step. Look and see what ratio is being represented and whether the value of that is positive or negative. That'll tell you which quadrants your answers will lie in. And in most cases, there's going to be two answers, two quadrants. We're going to see in some cases there will be four answers. There'll be answers in all four quadrants. Okay? And pay attention to the domain. It tells you whether you're working in degrees or radians. And it's not always going to be between 0 and 2 pi. Sometimes it might only be between 0 and pi. Sometimes it might be from negative pi to positive pi. So that's all going to affect how our answers are expressed. But in this case here, we're going from 0 to 2 pi. And also note, this says that theta is greater than or equal to 0, but less than 2 pi. So if we had an answer on the positive x-axis, right there, we could only use 0 as an answer, not 2 pi, because the domain says that theta is greater than or equal to 0, but only less than 2 pi. And this is often how it's expressed on the diploma exam. So pay attention to those things. Okay, so we know which two quadrants our answers will lie in. Our next step is to find the reference angle. And so this is where we use our calculator. With our calculator in radian mode, which I am, I'm going to go second function sine of 0.879. This is going to tell me what acute angle exists such that the sine of that angle is 0.879. In radians, it's 1.073. Now, it does say give answers to the nearest tenth, so we'll round that to 1.1 radians to write it down. That is our reference angle, 1.1 radians. And remember, the reference angle is always the angle between the terminal arm and the x-axis. There are two rotation angles here. That's your first rotation angle, where theta is 1.1 radians. And remember, you don't need a unit when you're talking radians. If you want to write radians, great, but you don't have to. Now, our second angle is that one right there. It's 1.1 radians short of 1/2 of a revolution, or 1.1 radians short of pi radians. So to find that value, I'm going to go pi minus my previous answer. Right? You always want to use your calculator. Use the entire values, not rounded values, when you're using them to calculate other numbers. And so it'll be 2.1 radians. So there's our two answers, 1.1 radians and 2.1 radians. Now, we can check these. And to check them, we would want to use the entire value that's in our calculator. The sine of that number, the previous answer, is exactly 0.879. You see, if you just do the sine of 2.1, a rounded value, it's not 0.879. It's close, but it's not, because you use a rounded value. So again, if we wanted to check the first number, which was 1.0737, I don't have that in my calculator, but I got it by going second function sine of 0.879. Oh, 0.879. Okay, that's where that number came from. And now if I take the sine of that number, I'll get exactly 0.879. So you should never get these wrong. They can always be checked. Okay? Looking at the next one, cos of theta is negative 3.66. And look at the domain. Now our answer has to be in degrees because theta is greater than or equal to 0 degrees, less than 360 degrees. But we start by drawing an xy axis. And I might as well do that for all of these remaining ones. That's always going to be our first step. And so now our cast rule tells us which ratios are positive in which quadrants. And in this case, the cosine of theta has to be a negative decimal, negative 0.366. The two quadrants where cosine is negative are quadrants 2 and 3. It's positive in the first and fourth quadrant. So these will be the two quadrants where our terminal arms will lie. So the negative sign on that decimal has done its job. To find the reference angle, which in this case is going to be in degrees, so I'm changing my mode. To find the reference angle, we go second function cos of positive 0.366. The negative sign has done its job. It told us what quadrants our terminal arms will lie in. So you forget about the negative sign when you are finding your reference angle. Your reference angle always has to be an acute angle between 0 and 90 or between 0 and pi on 2 radians. So we can see that that is 68.5. There's your reference angle between the terminal arm and the x-axis. Now, so I can check this property. I'm going to store this into memory slot A. My first rotation angle is 68.5 short of 180. So my first answer for theta will be 180 minus 68.5, which I've stored into memory slot A. So if I'll go 180 minus that value, I get 111.5, rounded to the nearest tenth. And I probably should use approximately equal to here instead, because I'm rounding it. So that's one answer rounded to the nearest tenth. To check it, before I go find the other angle, let's take the cosine of that angle. And I get exactly negative 0.366. So that angle checks. My second answer is in the third quadrant. It's 68.5 past 180. So that angle will be 180 plus 68.5. So again, because that 68.5 was rounded, my answer is going to be approximate. So 180 plus that number I put in memory slot A. Rounded, it's 248.5 degrees. And to check it, if we take the cosine of that number, we get exactly negative 0.366. Again, if instead of using the entire decimal, you actually use 248.5, the cosine of 248 just 0.5, it's close, but it's a little bit bigger than negative 0.366, or I guess a little bit smaller. But it's not exactly negative 0.366. So there's our answers to the nearest tenth, but if you're going to check them, you should use exact values by storing numbers in your calculator. So this one now, it says give exact answers because root 3 is on the unit circle. So just as a reminder here, let's draw the first quadrant of the unit circle. We have 45 degrees or pi on 4 in the middle. And then we're going to have 30 degrees or pi on 6, 60 degrees or pi on 3. And so remember, at this first stop, if you use the hand trick, put your second finger down. It's the root of this many fingers over 2, comma, the root of this many fingers over 2. Root 3 over 2, root 1, which is 1 over 2. At 45 degrees, you put down the middle finger, the root of this many fingers over 2, comma, the root of this many. Root 2 over 2, comma, root 2 over 2. And at 60 degrees or pi on 3 radians, you put the finger next to the thumb down, the root of 1 over 2, comma, the root of 3 over 2. It's the same two numbers from pi on 6, just in the opposite order. And for tangent, it's sine divided by cos. We saw that for pi on 6 or 30 degrees. 1/2 divided by root 3 over 2 gave us 1 over root 3, or root 3 over 3. And then we saw at 60 degrees or pi on 3 radians, when you divided root 3 over 2 by 1/2, it became root 3 over 1, which is what we need to use for number 3. Number 3 is asking, where is a tan of theta equal to positive root 3? Look at the domain. It's in degrees, but it goes from negative 180 to positive 180. So if you start at 0, negative 180 is there, all the way over to positive 180, which is coterminal with negative 180. So we're going to have answers potentially in all 4 quadrants, but in this case it'll only be 2, because there's only 2 quadrants where tangent is positive, because the tangent of theta is positive root 3. So it's only positive in the first quadrant or the third quadrant. And our unit circle tells us that our reference angle is 60 degrees. And that is the angle between the terminal arm and the x-axis. And so our 2 answers, the first one in quadrant 1 will be 60 degrees. In quadrant 3, remember, we're going in a negative direction. We're going towards negative 180. So it is 60 degrees short of going all the way to negative 180, meaning it would be negative 120 degrees. 60 degrees short of going negative 180 degrees would be negative 120 degrees. And if you're not sure if you're right or not, you can check. With our calculator in degree mode, which it is, when I take the tangent of these 2 angles, I should get root 3, which as a decimal is 1.732. And there's more because it's an irrational number, but we're going to see that they will either match exactly or not at all. When we take the tan of 60 degrees, we get exactly the same decimal. When we take the tangent of negative 120 degrees, we get exactly the same decimal. So our answers are both correct. Okay? Number 4 says the secant of theta is negative 2 over root 3. Here the domain is from negative 2 pi to positive 2 pi. So we want to be in radians. And we're going to have answers over 2 revolutions of the unit circle. If you start at 0 and you go to negative 2 pi, you're going to go clockwise 2 pi radians, which is coterminal with 0. And then from there, you're going to work in a positive direction, once around to 0, another trip around to positive 2 pi. So we're going to see, in this case, we're going to have 4 answers. 2 answers between 0 and positive 2 pi, and then another 2 answers between 0 and negative 2 pi. But first, we're starting with the fact that the secant of theta is 2 over root 3. And remember that the secant is the reciprocal of cosine. So the cosine of theta would be root 3 over 2. And because it's a positive, root 3 over 2, our answers will lie in the quadrants where cosine is positive, which is quadrant 1 and quadrant 4. To find our reference angle, you should recognize that that root 3 over 2 is from the unit circle. Plus it says give exact answers. So if we look above here, remembering that cosine is the x value, it equals positive root 3 over 2 at pi over 6 radians, this first stop. And again, we need to be in radians here. Our reference angle is pi on 6 radians. Whoops, there we go. So let's find our negative answers first. So in going in a negative direction, that angle there would be negative pi on 6. We're simply going pi on 6 in a clockwise direction. So that would be negative pi on 6. The second negative angle, going all the way around to quadrant 1, it's pi on 6 radians short of going negative 2 pi. One complete revolution around the circle in a clockwise direction, that's where this negative 2 pi came from. This is 1 pi on 6 short of getting there. And 1 pi on 6 short of 2 pi, which is 12 pi on 6, 1 pi on 6 short of 12 pi on 6 is 11. Negative 11 pi on 6. So those are the 2 negative angles. There are also 2 positive angles. So if I change my color here, here's my first positive angle going in a counterclockwise direction. That is positive pi on 6. And my second one, going all the way around like that, again, it's pi on 6 short of 2 pi, or pi on 6 short of 12 pi on 6. That would be positive 11 pi on 6. So to check these, our angles are in radians, so our mode must be in radians. And when I check each of these 4 angles, by taking the cosine of each of them, I should get a decimal, yes. That's general solutions. We're not there yet. So we should get answers that are equivalent to root 3 over 2, which as a decimal is 0.8660. So when we check these 4 angles, take the cosine of each of them, that's the decimal we should get. So the cosine of negative pi on 6 equals the right decimal. The cosine of negative 11 pi on 6 equals the same decimal. The cosine of positive pi on 6, yep, and the cosine of 11 pi on 6. They all work. So you should never get these wrong because you can always check them. You just have to make sure you're in the right mode. In this case, because our angles are in radians, Our domain told us we had to give answers in radians. So we put it in radian mode and we check the cosine of each of those angles. We get the right value. Okay? So, number 5. Tan theta all squared equals root 3. So that could also be written as tan squared theta equals 3. And in this case here, look at our domain. It's going from negative pi to positive pi. So that was similar to the one that we did a couple questions ago where it was negative 180 to positive 180. But now we're working in degrees. So in this case here, we need to know what tan theta equals, and we get that by taking the square root of both sides. And on the right side, when you take the square root of 3, the answers are both positive and negative root 3. Whenever you're solving an equation, you take the square root of both sides, there's always going to be 2 answers. So this is an example where we're going to have answers in all 4 quadrants. Because there are 2 quadrants where tangent is positive and 2 quadrants where tangent is negative. I mean, we can put the CAST rule in there, but we already know. There are 2 quadrants where tan is positive, and the other 2 quadrants, the tangent will be negative. So again, we're going to have answers in all 4 quadrants here. So there's an example, Miriam, where we have plus and minus. But we're also going to see it when we look at what are known as general solutions. And what general solutions are, it's where the domain is all real numbers. So it doesn't have a specific starting and ending point, except negative infinity to positive infinity. So we'll get to that. All right. Again, you should recognize that that value, root 3, is on the unit circle with respect to tangent. Question says exact values. There's another hint. But if we look at our unit circle here, our reference angle would be pi on 3 radians or 60 degrees, which we're going to be in degree mode. Sorry, we're in radians here. So it is pi on 3 radians. That's our reference angle, which is always between the terminal arm and the x-axis. So our answers are going to be from negative pi, which means from 0, if you go pi in a clockwise direction, you end up there, to positive pi, which is coterminal with negative pi. But it means that our 2 answers in quadrants 3 and 4 are going to be a negative rotation angle. The answers in quadrants 1 and 2 will be positive rotation angles. So let's find the ones in quadrant 3 and 4, our negative rotation angles. So the first one is fairly simple, straightforward. We're going pi on 3 in a negative direction. That is negative pi on 3. This next one, again, you're going in a negative direction. It's pi on 3 short of negative pi. So I can see the gears turning. Some of you have a little bit of smoke coming out of your ears. You want to give it a shot, Lohita? What angle would that be? Pi on 3 short of negative pi. You agree with her, Miriam? Yes. Yes. See, Miriam, I told you she was smart. You told me she doesn't know what she's doing. You did.
I've never said that.
Okay, whatever. Be like that. What about our answers in quadrant? What's our answer in quadrant 1, Jonathan? And what about quadrant 2? Yeah? And how can we know for sure? Putting in our calculator. So again, we need to be in radian mode, which we are. So when I take the tangent of each of these angles and square it, I should get positive 3. That's what I should get, because originally the equation was tan theta all squared, or tan squared theta equals 3. So if I open a bracket here, because I need to square my answer, when I take the tangent of negative pi on 3, close the bracket on the negative pi on 3, close the bracket on the tan of negative pi on 3, and square it, I get the right answer, positive 3. Okay, let's check negative 2 pi on 3. That works. Okay, let's check positive 2 pi on 3. That checks. And finally, let's check positive pi on 3. Also works. Okay, so should never get these wrong because you can always check them. All right. Page 211, numbers 1 and 4. And you're going to hand this in for marks. And Miriam, I think you should write a letter of apology to Luhita. Just saying it won't really mean anything.
I never said anything. Should I go get my textbook now?
I think, Luhita, I think those questions are in your package. Yeah.
Page 51.
Save you a trip.